Hey, how's it going, everybody? Today I've brought along another Leetcode problem. This is Leetcode problem number 217 in the category Easy, and it is called Contains Duplicate. Now, the question goes as follows. Given an integer array of numbers, return true if any value appears at least twice in the array, and returns false if every element is distinct. So let's have a look at two examples. If we have an input of 1, 2, 3, 1, then we're going to get the output true because, of course, in this sequence, the 1 appears twice. So there is a duplicate value, and in that case, we want to return true. Similarly, if we have a look at the second example over here, we have numbers 1, 2, 3, 4 in our numbers array, and there are no duplicates, so we're going to return false. There are several answers or several possible ways to solve this, so let's go through the brute force approach first. So if we have the number sequence 1, 2, 3, 1, then what could our brute force approach be? The way this brute force approach would work is that we take the first number, compare it to the second, compare it to the third, compare it to the fourth, and then in this case we already see that we have a match. Now say this was another number, say this was a 4 and not a 1, so let's make this a 4. Then in this case we would have to, since there wasn't a duplicate found on the first run, on the first comparison through this sequence, we would then have to move the number that we're comparing to all the others to the next one. So we would move on to 2, and we would compare 2 to 3 and 2 to 4, and we would go on and on like this through the entire sequence, right? So you can already see that we're going to require 2 loops. The first loop is going to be the one that takes care of this top part of moving the numbers through the sequence. And then we have the second loop down here, which takes care of the comparison that we did down here. So let's go ahead and write this algorithm. But perhaps before we do, let me just quickly talk about the time complexity and the space complexity. So if we have a simple comparison, so let me go ahead and write down the original sequence that we have in our example on the left-hand side. So when we go ahead and compare the numbers individually, so 1 to 2, 1 to 3, and 1 to 1, this is an O of n complexity. But this simple comparison is not enough, because remember we have this top loop that we also need to take into consideration. And that means that we have a time complexity of O of n squared. So the time complexity we can already write down as O of n squared. What about the space complexity? Now, regardless of how many inputs we have, the amount of space always remains the same. So in this case, we have a space complexity of O of 1. Let's go ahead and quickly implement this algorithm. So we're going to define an algorithm, and it is going to take nums as an input, and we're going to set output equal to false. And this output value is the value we're going to change depending on whether or not we find a duplicate value. So if we find a duplicate, we're changing output to true. But now let's take care of the 2 loops that we talked about earlier. This is the first one, this is the second one. So we're going to say for I in range length of the nums array, then an inner loop for j in range length of nums, and we are going to say that if I is not equal to j, so of course we don't want to compare individual numbers with themselves. We don't want to compare 1 to 1. We want to compare 1 to the next number So we of course don't want the index of the individual numbers in the array to be the same when we compare them. That's why we write not equal over here. But we of course then need to say that and nums I is equal to nums of j. Oh, hold on, I made a mistake over here. So if the index is not the same, but the numbers are the same, then we want to change the output equal to true. And at this point, as soon as we have a duplicate, we can break this loop and we can go ahead and return the output value. So then if we define an input sequence, let's take, for example, the sequence from our example earlier, 1, 2, 3, 1. And we're going to print algorithm. And let's input this sequence into the algorithm and go ahead and run this code. You can see that, well, let me make sure that I'm running this. Yeah, you can see that the console says true over here because, of course, in our input array, the number 1 appears twice. Now let's try and throw this off by maybe making the sequence a little bit more complicated, making this number 15. So now you can see there is no duplicate value. If we run it again, our algorithm notices this and it leaves the output as false because, of course, it does not find a any two numbers that are equal to one another in this array. And one final example, if we make this into 15, this final number, and run this again, you'll see that it returns true because, of course, our input array has 2 of the same number. Alright, so now I've gone ahead and deleted the answer that we've just come up with, our brute force approach, and we're going to try and optimize this algorithm a little bit by trying to think of another way to do this. And another way to do this would be to perhaps sort the inputs before we run our algorithm. So let's say we have the number sequence from our example earlier. So we have 1, 2, 3, and 1. And before we do anything with this, we're going to sort this array. So if we sort it in ascending order, we're going to have the 2 1s come first, and then the 2, and then the 3. So what's convenient about having this sequence sorted is that we only need to compare adjacent numbers to one another. Because of course, if we had other numbers that come up, the ones are always going to be at the very beginning stacked next to each other if this input is sorted in ascending order. So we only need to compare the neighbors, and that is it. So now let's think about the time complexity of this and the space complexity. So the time complexity is going to be influenced by the sorting algorithm that we run first. So whenever we sort, the time complexity of the sorting is O of n log n. But if we were to say, okay, this sorting does not play a role and we only need the time complexity of the actual algorithm without the sorting, so let's say we assume that the input is going to be given to us in ascending order, then we only have this single comparison where we run through each number comparing it to the adjacent ones, in which case the time complexity would be O of n. Now similarly, if we think about the space complexity, then what we can say here is that regardless of the number of inputs, the amount of space remains the same if we disregard the sorting, which would be O of 1. But this is only if we disregard the sorting. Since we have the sorting as part of our algorithm, we do need to be mindful of that. And the sort has a space complexity of O of n, right? So let me just maybe write an S next to this. So this would be the time and space complexity with the sort, and then without the sort, we would have this time complexity and this space complexity. So now that we know the time and space complexity, let's go ahead and write down the algorithm. So we're going to have the same beginning. We're going to define an algorithm. We're going to set the output to false. But then we're going to sort the numbers array. And by default, this sort sorts the numbers in ascending order. Then we're going to say that for I in range, length of the nums -1, and if the num at the index 1 is equal to the num at the index 1 I plus 1, then we want to change the output to true. And if that is the case, then we want to, or in any case, we always want to return the output. So let's go ahead and give this a shot. Let's write print algorithm, and we're going to pass in some input array. Let's make this first one without any duplicates. So as you can see, this input array does not have any duplicate values. And so what we expect, and that's exactly what also happens, is that it returns false. Now, on the other hand, if we go ahead and give this a duplicate value, so over here I've put in another 5. So you can see there's 2 5s over here, and if we go run this now, it returns true. So yeah, this is the second sort of solution that we can have. So right now we're just sorting the algorithm in ascending order, and after that's done, we're just comparing the neighbors with this line of code over here. You can see that we're comparing the number at the index I with the number at the index I plus 1. So I mean, if we were to look at this example on the right hand side, then this could be our number I. This would be I plus 1, and we would always be comparing the number next to one another. So that is the second way that we can go about to solve this algorithm, but there is a third way that I want to show you. Alright, so let's go ahead and have a look at the third possible solution. Let me write down the sequence that we had a moment ago. And what we're going to do now is we're going to check against the set of numbers if a value has already been saved into the set. So at the beginning, we're going to have this empty set over here, an empty set. We're going to take the first number and check if this number is in the set. And of course, at the beginning, the set is empty, so there's going to be nothing in that set. And that's why we're going to save the first number into our set of numbers. So the set is going to start off with a number 1. Now we're going to move from this number 1 to the next number, which is our number 2 over here. And we're going to check the set if this set already has a number 2. And since it doesn't, we're going to save the number 2 in this set. And similarly, we're going to proceed like this with the next number. So we're going to check, is our 3 in the set? If it's not, then we want to add the 3 to the set. And finally, when we get to this very last one and we check if it is in the set, we'll see that, hey, yeah, now we do actually have this one which we stored at the very beginning within our set. And so we're going to be able to say that, yes, this is a duplicate value, and we want to return true. So before we go ahead and code down this example in our editor on the left-hand side, let's talk about the time and the space complexity of this. So the time complexity, we only need to scan this list one time, so it is going to be O of n. And similarly, we do need to give up on a little bit of space complexity compared to the very first example where we had a complexity of O of 1, because in this case, we actually do need to, our space complexity does in fact increase depending on the number of inputs. Specifically, it is going to be O of n. So let's go ahead and write down this very final example in our editor on the left-hand side. So we're starting again by defining an algorithm that takes as a parameter this numbers array, and we're going to set output to false. Then we're going to define a hash set, which is going to be equal to an empty set. And we're going to say that for num in nums, if the number in the hash set, then, so if the number is in the hash set, then we want to set the output equal to true. Otherwise, if that isn't the case, then we want to add this number to the hash set, like we discussed a moment ago. And at the very end, we want to return the output. So this is exactly what we talked about on the right-hand side. You can see that if the number that we're currently investigating is in this hash set, then we of course want to set the output to true. However, if it is not the case, so if the number is not in the hash set, then we want to add it to the hash set, which is exactly what we did earlier on the right-hand side. So now let's pass in some example. We're going to print algorithm, and let's pass in some arbitrary set of numbers. You can already see that in this set of numbers there is a duplicate. We have 2 5s. So if we run this, it should return true, and you can see that it returns true. Now let's try and throw this off by giving it perhaps a little bit of a more complex sequence. You can already see that there are 2 2s in here at the beginning and at the end, so it should remain true. Now if we remove all the duplicates, then you can see it returns false. Alright, so these were the 3 ways to solve this contains duplicate example. And yeah, let me know what other coding questions you would like me to solve down in the comments below. I hope you enjoyed this episode, and see you in the next one.